Explosive storage tanks or containers are specialized vessels or enclosures used in industry and defense contexts to hold energetic materials, propellants, or precursors under controlled conditions. This overview describes high-level concepts rather than fabrication or handling procedures. Storage choices depend on the chemical and physical properties of the stored material, including sensitivity to shock, heat, friction, vapor pressure, hygroscopicity, and long-term stability, and these properties drive design, monitoring, and operational rules. Regulatory frameworks govern storage and transport of energetic substances. Licensing, siting restrictions, permitted quantities, segregation rules, and transportation regulations are enforced by national and international agencies to protect public safety and the environment. Facility design focuses on risk reduction and containment at a system level, zoning to keep hazardous stores away from populated areas, engineered barriers and blast mitigation measures at yards and plants, ventilation and inerting strategies for vapor control, and fire-resistant construction for surrounding infrastructure. Environmental control systems maintain conditions that reduce degradation and unwanted reactions. Temperature control, humidity control, and controlled atmospheres are applied conceptually to improve shelf life and lower hazard potential for sensitive materials. Monitoring and detection are central to safe operations. Continuous condition monitoring, gas and vapor detection, intrusion detection, and inventory reconciliation support situational awareness and early warning without giving procedural details. Handling and logistics emphasize organizational controls and training, authorized personnel, documented procedures, certified transport containers, and strict chain of custody practices reduce human error and unauthorized access. Certification and recurring competence assessments are standard in regulated sectors. Emergency planning and response are key topics. Coordinated incident response plans, evacuation and sheltering strategies, mutual aid agreements with local authorities, notification and communication protocols, and environmental remediation planning are typical components of preparedness efforts. Historical incidents illustrate systemic lessons. Major accidents involving stored energetic materials have often resulted from combinations of human factors, inadequate segregation, aging stock, or failure to follow regulation. Post-incident analyses inform stronger standards and engineering controls. Safety culture and governance include risk assessment, hazard classification, periodic audits, third-party inspections, and transparent reporting to regulators and stakeholders. Continuous improvement and learning from near misses are emphasized. Environmental and public health considerations address contamination, air emissions, water runoff, and long-term site remediation obligations following release events. Community engagement and clear information channels are part of responsible operations. Security and safeguards cover access control, background checks for personnel, inventory controls to prevent diversion, and coordination with law enforcement and regulatory bodies to mitigate misuse risks. Testing, certification, and standards are handled by accredited bodies. Materials testing, aging studies, packaging certification, and compliance with national technical standards and international guidelines form the technical backbone of safe storage practices. Research and safer alternatives explore formulations with lower sensitivity, improved packaging technologies, inerting approaches, and logistics strategies that minimize on-site quantities through just-in-time supply while meeting legal and operational needs. Ethical and legal context stresses that work with energetic materials must occur only within licensed, regulated programs and facilities staffed by trained professionals. Unauthorized experimentation or sharing of operationally actionable details is illegal and dangerous. Safe learning paths include studying chemical engineering, materials science, explosive safety and handling courses from accredited institutions, attending regulator-approved training, reading accident investigation reports for lessons learned, and working under supervision within certified facilities. Visual suggestions for video subtitles include labeled diagrams of storage facility layouts, conceptual comparisons of containment and mitigation strategies, timelines of major historical incidents with lessons learned, overlays of regulatory and emergency response roles, and calls to pursue formal education and regulated work.